In a previous video, I demonstrated how you could construct JUnit 5 tests using essentially a AAA mechanism. In this video, I'm going to take TestNG and use data providers, which is a really powerful concept to start to head in the direction of data-driven testing, to start to simplify our domain tests that we're going to do for this problem. So our goals here is we want to explain how to construct some TestNG using data providers. The key thing to doing this is these data providers really cut down on the complexity of our tests. So just to review things here, when we have a test, we really follow three steps. We set up our initial conditions for our test, we perform some type of an operation on that test, and we verify that that operation has been completed properly. Those are the three steps that we do with every type of test, especially down at the unit test level. Expressed slightly differently, we can talk about this as AAA testing, where we start by arranging our tests, or arranging our initial conditions, the setup. We act upon that by doing something with the class that we're going to test, and then we assert that the results have actually turned out to be what we want them to be. So those are the three steps in this AAA format for testing. The system that's under test is a word processor. Well, kind of a word processor. Basically, this word processor, you can type along, and every time you hit the space bar, you would add a word to the list of words that are in the word processor. The word processor can be initiated or instantiated with no words in it, or you can have a list of initial words that were started up. So a document that you had typed previously could be brought in as a list of words. We can also print the document out, where that printing of the document gives us basically a string back. Now, using input domain analysis, we can split our methods in this and look at the different characteristics that would be present in the inputs. Our constructor, obviously, our base constructor has no parameters and doesn't really impact the internal data. What it's doing is effectively returning a new instance of the class. We can take a constructor and pass in some initial words, and we are also getting back a new instance. Now, this constructor may have different behaviors depending on whether initial words is null or not. So if this is a null parameter being passed in, the way it's defined in the Java doc, that's going to cause an exception. We can have initial words be a list with 0, 1, or more valid strings in it. So these could be 0, 1, 2, 3, 4, 5, any one of those numbers of strings in it. That's going to return something that's initialized. I could have, if I kind of shift these criterion because I got a little bit out of alignment here, I can have initial words be a list that contains a null string. If it has a null string in it, then what we're going to do is we're going to throw an exception. That's invalid. Last but not least, we have a list which may contain a string of length 0. That's another characteristic. So all of these characteristics impact these initial words. Adding a word, we are dependent upon the words that are internal to our system, the words that have been previously typed, and the next word that's passed in. The return for this method is going to be the length of the word list, so how many words are on the list. And what we can do is find out that there is a set of criterion that's going to impact this. So words has 0, 1, or more words on it. That internal data is going to impact the behavior of this system. The other thing that will impact it is the word itself being null, an empty string, or 1 or more characters in length. This here is again a criterion that will impact the behavior of this AddWord method. Now C2 here, this is essentially the same criterion that I had up here for the constructor. We're going to find that to be very useful when we start using data providers. Last but not least, we have print document. Print document basically concatenates the words together and gives it back to us. Our criterion for this is actually covered by criterion C2 again, and my return is the words concatenated together. So what is different about print document is essentially the expected values, not the test criterion that I need to use for actually testing this method. So here we are looking at the basic TestNG setup. At this point, what I've done is I've created a basic TestNG test, and it's set up structurally very similar to how you would have a JUnit test for this. We have a private instance of this word processor that we're going to set up. I have a before method system that will instantiate a new instance of the word processor, which in this case is just going to be an empty, no word instance of the word processor. And then I've got a test of the basic constructor. Now, this test of the basic constructor, all it's going to do is verify that if I start with an instance that is null, I instantiate a new instance of the word processor using this empty constructor, that I'm going to get it back a valid instance. Really, this test here is pretty straightforward and pretty primitive. Very rarely is this going to give us a problem. So right now what I can do is I can run these two tests. Or run this, not two tests, this test. And we can see it passes. Now, what I would like to do is start to do some of these other tests that I have in the system. So, for example, I might want to test these conditions, C1, C2, C3, so on and so forth. So in order to do that, what I'm going to do is create a data provider. So the data provider in this case is going to be for these C1 criterions. Basically, the C1 criterion that we're going to care about is essentially the case where we pass a test or pass a initial value that is null. So if I pass an initial value, what is going to happen is I am going to expect that I get an exception. So I'm going to set this test up here. This test long constructor essentially takes in the string words, and in this case, for the tests that are passed by this C1, really I should call this C1 exception data provider, and then down here I'm going to call this C1 exception data provider. These are the data items that will cause an exception to be generated. Now in this case I've only got a single one, so it's not quite as useful to use the data provider structure as we'll see in some of the later cases, but it does get into the concept that I have essentially a table definition right here, and then I run this test once. What this table or data-driven testing gives us now is the idea that my initial conditions and my parameters can be defined in a table, and then this test method, instead of worrying about the data and the setup and things, just does the execution for things. Now next up, what I want to do is I want to take a look at these C2 scenarios. So in C2, what I'm going to have are instances of valid strings that I could pass into this constructor that would create valid items. So here we have the C2 data provider, a new string that is empty. That's going to be a valid string for constructing things. If I have a string that's hello, or if I have a set of strings here that is hello and world. What we have here is essentially 0, 1, and there actually syntactically is a problem there. That parenthesis needs to, or that, not parenthesis, that bracket needs to go out there like so. So I have 0, 1, and 2 words on my list, or that are going to be my initial conditions in the words. I pass them to this data provider here, which is going to give me valid parameters. And what happens is I'm going to assert that this is constructed properly. So here I'm testing the constructor again. Right here are my data items that are passed in that are going to be tested, and I can run, set this to be public. I can run just this one test here for right now, and we can see what happens. And we can see that all 3 of those conditions worked properly. Now you notice that when I did this previously with the JUnit tests, I actually had 3 test methods. Now what I've got is a single data provider that's giving me 3 different instances of data. That helps to cut down on our test cases. Now, if I go to C3, based on it, C3 essentially is a list which in this case contains a null string. We're going to kind of be back to a couple of different types of tests that I might want to have. So if I think about C3 having a null string in it, there's an example where I have a null string in the middle. Maybe I would want to come up with a couple different variants on this test. So maybe I would like to have null, typing. I want to type hello in here first, like so, and world. Maybe I want null to be the 0th element of the array that I pass in as an initial condition. Or maybe what I want to do is I want to test it where it is 3rd instance. So now we're starting to see the beauty of the data provider here, in that I can come up with these different sets of values. They're all going to be passed into this method here. And really, I should again call this a C3 exception data provider. And down here, the C3 exception data provider. Each one of these will cause an exception to be thrown. So running that, we'll see again that all 3 of these test cases passed OK. Next, now what we want to do is C4, which essentially has, in our case, a list of a string that is empty. So this again should throw an exception. So my initial cut here, what I've got is I've written a C4 exception data provider, and then I'm going to call this a C4 exception data provider. But here is an interesting thing. If you look at this, this code down here is exactly the same. The structure is exactly the same. What I can actually do now to combine things and make things a little bit easier for me to keep track of, I can actually move this up into this previous example here. And I can also take and put a couple different variants of it together. So maybe I want to put the empty string in the first spot, and maybe the second spot, and then I'll put it into the 3rd spot. I have actually moved those tests up into the data provider, which means I can actually do both C3 and C4 types of tests with this setup that I have here. That means I don't have to actually duplicate the code here with these others. But what I do need to do is to indicate with a comment that essentially tells me that this table provides both C3 and C4 tests. Moving on then to the next step, I've done C1, C2, C3, and C4 here. What I need to look at is testing the AddWord. Now, in AddWord, I can actually do some of the same things that I did with my C2 data provider. See, if you remember, the C2 data provider that I've got defined up above here provides me with an empty array as an initial condition, 1 word, and 2 words previously there. What I can do to test, since I have that data provider in place there, and since my AddWord has a dependency upon 0, 1, or 2 words on the list, I can actually just define a different test case here. This is now going to use AddWord, where my initial conditions come from what I have for the C2 data provider. So now AddWord is automatically going to cover things, and I can test all of those different conditions. All I've had to do is write the behavior different for the test. The initial conditions and the values that I use are those that I defined up above. Going to our table here now, C5, what I have to do is look at the word as being null, an empty string, one or more characters in length. So we've got some tests there that I want to do. Now in that scenario, really it's not dependent upon entirely what my state of the initial word is, or or what's on the word lists. What the dependency is on the parameter that's passed in as part of the method. So I'm going to do my data provider just a little bit differently in this scenario. In this particular case, what I'm going to do is I'm going to take my data provider and it's going to provide both the data and then it's going to have a piece of information telling me whether or not I have an exception being generated for that given method. So let's take a look at the data provider first. So the data provider that I'm going to be adding into this method here basically takes scenario I have null as my word that I'm being added. If it's null, I want it to throw an exception. If it's empty, I want it to throw an exception. If it's a single character, I don't care. If it's multiple characters, I don't want it to throw an exception. So these are my test cases I'm going to pass in. And again, you can see how very, very easy it would be to add more test values into the system. My test, the way it is written here, what it is going to do is I am going to instantiate an instance of the word processor here, arrange it. My initial conditions for this is going to be hello world, just because those are the initial words that I want on my list. And then what I'm going to do is I'm going to act. Now my act is a little different in this scenario here. My act, I'm going to have it inside of a try-catch statement because I'm dealing with this Boolean that tells me whether it's thrown or not. And really I should probably put a comment in place. So I've got both in this case the data that I'm going to add and what I'm expecting to have happen getting passed in. I try to add the word, getting back to length. And if throws exception is true, I should never get to this point because I should throw an exception, immediately go down to this catch. And if it was supposed to throw an exception, we're okay. If for some reason this throws an exception and it wasn't supposed to, we'll come down to this fail and we'll say that an exception should not have been generated. If this does not generate an exception, what we'll do is we'll assert that the length is equal to, when in our case should be 1, 2, plus the word to add, giving us 3. Last but not least, I want to test the print document. Now the print document, if we look at our test case, really our print document is essentially completely dependent upon criterion or the characteristic 2 that we set up for our testing. So characteristic 2 says that initial words is in our case a list with 0, 1, or more valid strings in it. So I can actually take and use the C2 data provider that I wrote previously and write a test case here that what it will do is based upon the initial words, I'm going to generate myself an expected string in terms of the assert. I'm going to assert the two are equal. And at this point, everything will be all fine. And I can run again this test here once I throw the public in front of it. So running this test, we'll see how this all works here. And that works properly. So we can see how these data providers really come in handy. So now that I have all of these tests constructed, I can very easily run the entire test suite, and I can see that all of the tests are passing properly. I can also see that it would be very easy for there to be problems if there was a bug in my code. So, for example, what I'm going to do is I'm going to require that the length of the word in the AddWord to be essentially greater than 1. Otherwise, we'll throw an exception. So what that would do if I run the test is it would not allow me to add single character words. If I go back and run my test that I have just created here again, what we will see is that I ended up with a single test failing. I can go through here and I can see exactly in this scenario that an exception should not have been generated. What I was doing is I was passing in the character A, and it should not have generated an exception. So I look at my test here. A was the word to add, so I can go back into my word to add word. Oh, there's the bug that I just injected there a moment ago, and I can fix it, and I can then rerun all of my test cases, and we can see very easily now that all of them pass. So we've seen the benefits of using data providers. We've seen how we can use the input domain analysis to help us construct our data providers. We have a really beneficial structure for testing purposes. That brings this video now to a conclusion.